Hello, my name is Anthony Romanello, and today I'm going to be walking you through a tutorial on how to make your own ERC20 token with absolutely no coding experience. This is going to directly follow along with my guide, how to create your own crypto coin with no coding experience. That's on my blog at anthonyromanello.com, so go check that out. We are going to be using the Remix Ethereum IDE. IDE stands for Integrated Integrated Development Environment. Basically, when you develop anything, you have to set up an environment, download a bunch of programs, a bunch of plugins. I use VS Code personally. You could use like Atom. There's a ton of things you could do, but essentially this allows you to code and develop without having to download and go through all of that. So, and also I just want to show you the ERC20 token standard really quick. And I implore you to go look at this, the Ethereum's website, and go over the documentation yourself. Basically just details what an ERC20 token is, the functions that are got to be included to make it an actual token in the standard. I'm also going to be utilizing OpenZeppelin's library. We'll go over that in a second, but it's a great resource to help develop smart contracts. We're also going to be coding in the Solidity coding language because that is what you use to develop smart contracts. All right, let's jump right into this. So when you type in, so to get to this Remix Ethereum IDE, you got to type in remix.ethereum.org, punch that right into the Google search bar, and you'll get thrown onto this website. It'll start you off with the default workspace. I want you to go and hit this button right here, create a workspace. You can call it whatever you want. I called mine the workspace Romulan token. After that, we're going to go ahead and make our first file. My token.sol. The sol at the end, the .sol, that stands for Solidity, the coding language we're using. We're going to go over here and click on the Solidity compiler. It's a little Solidity icon, and make sure we're using the most current compiler, and I have it selected already. And we're going to hit auto compile also, just so anytime we type something, it auto compiles it and make sure that everything's running properly. Gonna have a sip of my Rick and Morty coffee. All right, so first thing we're going to do when you write any smart contract, you got to declare the Solidity coding language version that you're using. We are using 8.7. And let's just declare the contract. You could have called this anything you wanted, but I think it's just easier if you use my token. And that's it. That's the smart contract. Now, but basically, that's really, how the smart contracts, a lot of them, have minimal lines of code. We want to give our smart contract, we don't have to do this, but it makes it a little bit easier. We're going to first declare a constructor. Constructor is just something that gets called first. And we are going to give our token, and when I say first, I mean, when we compile everything and run the file, the constructor is the first thing that gets called, and whatever's inside the scope of the constructor, scope means within like the bounds of the constructor is what is going to get run first. So we could declare things to happen initially, which, we're going to do right now. So in the constructor, we're going to say that our token's name, I'm just going to call it my token. You could call it anything you want. And we're going to give it a symbol. I'm going to give it a Romulan symbol. And now anything that is in between these two little squiggly brackets is called the scope of the constructor. And anything that's in here is going to be run first. Okay, so now we are going to use OpenZeppelin to help write this contract. The reason this tutorial requires no coding experience is because we're going to use the OpenZeppelin library of amazing resources, and it actually gives us like a ton of functionality that is already made for us. So just type in, you could type in like OpenZeppelin GitHub on Google, the first choice should be the OpenZeppelin GitHub. You're going to go over here to OpenZeppelin contracts. And we're gonna scroll down. Am I recording? I just want to make sure I'm recording. We're gonna scroll down to contracts because we are developing a contract right now, smart contract, right? And what kind of contract? A token. So we're gonna click on token. Now I'm pointing at the screen, you can't see my hand. There's 4 different contracts here, and these are all, the pretty popular ones. I myself have made an ERC20 and a 721. I'm working on the 1155 right now, but if you want to develop, after this tutorial, come here, look at these contracts, see how to use them. They got great information in here. We're doing an ERC20, so we're going to click on that. In here is a ton of amazing information regarding the ERC20. We are going to click on erc20.sol, and this is basically our smart contract, right? So contract ERC20, it goes over how the contract works. Essentially, it's got this mapping stuff here. We map an address to, well, and here it's mapping it to a private balance, but usually we want to map like an address to an admin or something like that, like a token address. And when I say token, sorry, not token address, I mean account address or like a wallet. So if I have myself a MetaMask wallet. This is like an account that represents me on the blockchain. Romo's wallet. Saw some Shibu in there, wasn't a great purchase. But yeah, here it details the name, the symbol, so all the functionality. Basically, we're going to go ahead and take this URL and we're going to copy it and we're going to throw it at the top of or not at the very top, but we're going to import it into our document. So you just type in import. Hit that, you paste that in just like that, and now it is imported, and we actually have access to all of the methods and functionality that are listed in that GitHub, which is awesome. The only thing left to do is take the my contract my token and just write is ERC20, and literally this is now an ERC20 contract. We, like I was talking before about mapping everything, we want to map up here. We want to say the address is public, and we're just going to declare an admin, and we're going to actually set the admin inside the constructor because the constructor runs first. We want the first thing to be, the first thing that's there is to assign the admin to someone. So we're going to say the admin equals msg.sender. msg.sender, essentially, whoever the person that deploys the contract, which is going to be us, is going to be msg.sender. And the person and we're setting that to be the admin. So the person that deploys the contract, us, is going to be the admin, and we'll see more of that in a second. So we declared that we have the admin, and we have this token, right? The token doesn't have a total supply yet, but we could totally throw that in there. So let's do that. We're going to actually make a call to the mint function. Where is the mint? All right, here, our underscore mint. This essentially allows us to create more tokens if we wanted to. So let us, and we're doing this in the constructor because the constructor is going to call this mint function when the contract is deployed and make all of our tokens. So I hope that makes sense. So the reason we're putting this in the constructor is so when the constructor runs, we're going to get a token name, my token, and a token symbol, ROM for Romulan. We're going to mint the tokens, right? So we're going to create a supply of tokens. And then we are also going to assign the admin to be msg.sender, which is the person that deploys the contract, which is us. I hope I didn't lose you there, and I hope that makes sense. So we're going to call the minting function. The first argument given is going to be msg.sender. And then we're going to make the supply. When you do the supply, and when you're developing Ethereum has up to 18 decimal places. It uses something called way, like how we have like pennies, nickels, dimes, like we have some type, we have smaller a smaller distribution of the decimal. So does Ethereum. Ethereum's smaller distribution is called Way. And essentially, we have to make sure that we're using all the decimal places. So let's just say we have 10,000 coins, and we're going to say we have 10,000 to the times 10 to the 18th power. That's essentially what this is saying. Like, if you remember the scientific notation, you would like move the decimal place like a bunch of times over. That's just essentially what we're doing here. We're giving ourselves some decimal places. Close that off. So far we have the name symbol, we declared the admin, we are minting the tokens, and when we mint the tokens, they're going to be sent to the msg.sender. I'll show you guys that in 1 second, but the person that deploys the contract is msg.sender. They are minting the tokens, and the tokens are being put into their account. Essentially, our token is done right now. You could publish this on the blockchain and it has all the functionality to be traded, and you can approve the token, you could trade it, and everything like that. Everything that's detailed in the documentation here. You can transfer it, give it an allowance, transfer from function, approve function. So you could do all of this just because we imported OpenZeppelin up here and said it's an ERC20. You have, if you've made it this far, you have successfully created your own smart contract. But let's deploy this guy. And I know it's like, you might be thinking like, that's it. Literally, that's it. It wasn't that many lines of code. Developing smart contracts is very easy. Now, this is a very basic smart contract for the ERC20 token. You know, you really can't do too much with this. You can go on my GitHub and see some of my other projects. I made a lot stronger ERC20 tokens that can be loaned and staked. You can add other functionality to this. Like right now, before we continue, I'm gonna just add some functionality to mint more coins if we wanted to. And it would just, I mean, you don't have to do this, but it would just make more sense. Like, I don't know why you would want to do this, but they have, you know, some tokens, if you wanted to make more, you have the, can't spell, you have the option to make more. I'm going to call mint, and it's going to send it to the person and with the proper amount. And so right now we set up a mint function. Anyone who interacts with this contract can call on the mint function, and that is not, you know, secure. If we were to post this to the blockchain, once you post it to the blockchain, it can never be changed again, you know? So you want to make sure whenever you publish something to the blockchain, it is very safe and secure. If we were to post this and we have all the coins in our account, like let's say, you know, we have the 10,000 coins in our account, someone can go to the GitHub, go to the smart contract, and just run it again and have this, you know, have 10,000 tokens in their account now. And now your 10,000 tokens, you know, aren't worth as much, and you just experienced inflation. So we don't want that to happen. We're going to put some minor security in here real quick. We're just going to give it a require statement. This essentially just make sure that the require statement, we're going to say that the msg.sender has to be the admin, which means the person that first deployed the contract, and it can only be the admin. A computer won't know to do something unless you tell it to. It needs logic. We just gave it a very small amount of logic that if you are not the admin, you cannot mint this coin. msg.sender equals admin. That's correct, right? Close it off. Close that off. All right, so we made our minting function, and then the last thing I want to throw out to you guys is a burn function. So let's say we called the minting function and made way too many coins, and we want to deflate our token. We totally could do that. We can burn our tokens. These two things are completely optional to the ERC20 standard, but I think they're good to have, and they're on my other coins. So we're going to call the burn function here. You might want to, you know, if you were actually going to develop and post this, you might want to also add a require statement here, because it would suck if some random person burned all the tokens. So amount, I just want to make sure I have everything spelled correctly. Okay, good. So essentially our contract is finished. Everything I want to throw in there is there. Let us go over, everything's compiled right. All right, so let's go over here. We are going to, this is it's the third thing here. It's like a little Ethereum symbol. You're going to click it. It's deploy and run transactions. We're going to choose our environment to be JavaScript VM. This is going to be a local blockchain. This is why I love Remix. I don't know if I mentioned this beginning. I forgot to. If I didn't mention it, obviously. But this Remix is so powerful because it has a local blockchain already set up and implemented. With my other projects, I had to use something called Ganache, and I had to hook it up separately. I had to hook up to MetaMask. It was like a whole process of setting up a local network and everything like that. Once you learn how to do it once, it's not that hard. But for someone with no coding experience, it would have been a real hassle to set up a local blockchain for development purposes. So Remix is really great. You click environment, click JavaScript VM. It gives you a bunch of accounts full of Ether. They're not real Ether, it's development, it's a local blockchain, but so this is awesome. So it's going to deploy it with the first account being the deployer. This first account is going to represent us for right now. Let's hit deploy, and it deployed it. Oh wait, did it not deploy it? Is it going through? Are we missing anything? My token. Just want to make sure this is going to come out right. What's going on here? Sorry, guys. We have memory capacity here. Oh, there we go. Sorry for that little hiccup. This is the first time I experienced that using Remix. Maybe it's not that great. No, it is great. I don't know what those two other things, why that didn't happen properly. I think I just was rushing it and clicking it too many times. All right, so we ran the contract. Whenever you deploy something, and I was like, oh, that was scary. Whenever we deploy something, maybe I'm leaving that error in. It's good. Maybe you guys will experience it too. And I don't know, I just waited and it seemed to work. Whenever you deploy a contract, just in general, even if you're not using this local blockchain, if you are on the main Ethereum network, it's going to cost some Ether. It's going to cost a gas fee to deploy. So you can see that we did spend a little bit of Ether deploying it. And now let's interact with the contract. It's deployed. Congratulations, you deployed your first smart contract. You created a token. You really did. It doesn't seem like it because it seems like we're not doing too much, but we really did. So I want you to go over here and click copy value to clipboard. This is going to be the first account. All of the tokens should have been, don't look at my addresses. All of the tokens should have been sent to that first account. We'll see that with balance of here. So I took the first account, I called the balance, and also all of these functions, this is all of the functionality our contract has because we said is ERC20, and then we put the mint and burn functions, which you could see the mint function and burn function are right there. And all of these other things are here just because we said is ERC20. So I that's amazing to me. I love Remix because it gives you this great visual to call all these functions. Usually you would have to type in a bunch of code mumbo jumbo and then it'll spit out a response. But I'm rambling here. So we see the balance of that one account is the 10,000 tokens to the times 10 to the 18th power, exactly like it should be. And now let's actually transfer these tokens from one account to another. So we have the transfer function here. Gonna paste it as plain text. Sometimes, and maybe if the error happens, I'll leave it in the video too. Sometimes when you're copying and pasting it, you might get an extra space, or it might just do something with the formatting. Just post it as plain text. Sometimes I ran into an error with that, and it was literally just because of that. We're gonna go to the second account here, and we are going to copy that, and we are going to transfer. And I want to mention, so how does the contract know where to transfer the tokens from? We only put in the receiving address. Well, it's sending it from MSG sender, and MSG sender is the person that deployed the contract. So if we look here at the transfer function and we call underscore transfer, MSG.sender is the first argument. So that's the person that's going to send it. Then we put in the recipient, and then we put in the amount. So we put in the address we're sending it to and the amount, and it is going to call the transfer function. So let's see that happen. That exceeds the balance. Yeah, I was expecting that to happen. It's no big deal. Let's try doing it again. We're gonna, and the error is here, so I'm definitely leaving it in the video in case it happens to you guys. But you could go ahead and hit that arrow and open it up so it's a little easier to see. And then we're gonna go right here. Copy this guy, paste it. Let's give it a 0 or 2. Send it to the right guy. I might be clicking too quick and now it's getting messed up. Holding my token. All right, so we still got that in there. Let's see how much the second account's got in there. Wait, is that the second account? No, it's not. All right, let's paste in the second account. Let's make sure that, nope. Sorry guys, copy this. Trying to do it all in one take. All right, so you can see that, well, at least, you know, so the balance of the account, that second account is 0. Let's paste that in there again. And recipient is that second address. Now it's pending. Oh no, I don't like that at all. Let's check how much is in there now. Because I hit it twice. God dang it. Well, you know, it usually gives you like a check mark or something to let you know that it did it. It apparently did do it because I just checked the price and it says that it has the tokens in there. If you follow the blog, it gives you a picture of like a check. Let's see how much the original things got in here right now. Okay, so I mean, so it did transfer it. The transfer function did work. Definitely gonna leave this error in the video just in case you run into this. Don't get spooked. Sometimes, and it's because I'm recording this video, my processor is using a lot of power and I got a bunch of things up, but I'm clicking too fast and it, you know, it says it's pending. You have to just let it go. If I wasn't doing the video, I would have let it go, but so you can see that it transferred. Let's just transfer. So we hit it twice. Let's just put a 2 there. We'll put the original count. And you can see the original count balance is like that right now. Let's transact. And yep, and look at that. So the balance, so it's not giving us the weird check for some reason. I don't know why it's not doing that, but it is giving the transaction and giving the proper amount, and we could see that the token amount did change. If you didn't catch it, rewind the video real quick and do it. But so look at that. We were able to actually interact with our smart contract, develop on it, you successfully made your own, in your first ERC20 token, you added a burn and mint function to it. You were able to use a local blockchain and send the tokens amongst them. Now, if you watch this because you wanted to actually put the coin on the mainnet, I'm going to show you how to do that too, but be wary that you might want to do a ton of more research, because this is a very basic token and doesn't have too much functionality outside of what it should in the standard. And that's fine. There's so many tokens that just have the basic functionality, but as tech is improving, you kind of want your coin to have more utility. Dogecoin, for example, has absolutely, I'm not even going to talk about other coins. There are a lot of coins out there that have absolutely no utility. So your coin is probably not going to get lucky like some of those other ones and fly to the moon, just because the utility is a meme. So if you can't have utility, I would not really publish a coin. But go up here, our environment, we're going to make it injected Web3. This is an environment for the mainnet. It's going to ask to hook up to your MetaMask account. So make sure you have a MetaMask account already set up. You want to have some Ether in it, because if you're going to publish it to the mainnet, it's going to ask for some Ether. At the time of me making this video, there has been a ton of Ethereum traffic, and I know that the gas prices are going to be high. So just like how we hit deploy before, we are now going to deploy, and it's going to attempt to put it to the mainnet. Also, with the accounts here, you notice there's only one account. It's my account because it's connected to my MetaMask, and trying to post it to the mainnet. So this is for real. So you can take everything we just did and put it on the mainnet. You can go ahead and call this token, I mean, I made Romulan tokens already, but you could call it Romulan 2, and we're making a second Romulan type of token, and romp. That's the new symbol for this token. And we're going to try deploying this. It's going to give us a warning saying, hey, listen, you're going to confirm this transaction. It's going to go to the mainnet and cost all your money. It's got Gwei right here, which I was talking about earlier. And I'm just going to confirm it to show you guys how much it would ask me to publish this. Let's see, what does it say? All right, so when I tried doing it this morning, it said $1,000. Right now it's $725. So we're running a a gas fee sale right now. I have insufficient funds. I'm not going to do this just because it has no utility and I don't have enough to do it. It would probably be bad on my end to actually deploy this, but that is how it would go if you were actually trying to deploy this on your own. So there you go. So we create our own token. We are able to deploy it and communicate with it on a test network and on a local blockchain development server. If you wanted, you really could deploy it to the mainnet. It's going to cost you some Ether though, and I highly do not recommend that. I would definitely do a lot more research and make sure everything is safe and secure before you publish it. Like I said, this follows along with my blog. This video is definitely running long. I really only wanted it to be a few minutes, but there's a lot to talk about, and we experienced some errors, which I want you guys to see too in case you run into them. So that's all I got. I hope you guys learned something. If anything, I hope you learned to navigate OpenZeppelin GitHub, import it, and then make an ERC20. You could do the same exact thing with the 721 and the 1155, and then add some extra things in there. All right, I'm gonna let the video end because I just keep rambling. All right, bye guys. Thanks for your time.